So my experience teaching inequalities in Math 095 has been that most people get pretty good at solving. But this interval notation thing continues to be a source of confusion for people. So let's go through the solution part real quickly, and then we'll maybe spend a little bit more time talking about notation. And again, notation ultimately at the end of the day is not that crucial for us. The solution is much more interesting because that's where the mathematical reasoning comes in. Writing your answer in interval notation, that's almost not mathematics. It's more of a communications tool than it is anything else. We can also talk about what the solution would look like in set builder notation. But these are really just ways of expressing a thought rather than ways of actually solving problems. So that's meant to be kind of reassuring that if you're struggling with interval notation still, you're struggling with something that is less about can you solve math problems and more about can you communicate your answers in a specific way. So let's do the solution bit. 3x plus 17 is less than or equal to 8x plus 14. How are we going to solve this inequality to get the x by itself? What's going to be our strategy? What's the first thing you want to do here? Yeah, so I've got whole numbers in everywhere. I turn out not to have any fractions here. I have them as coefficients of x, and I have them as constant terms. But then those are distributed across both sides of this equation. So if I want to get the x by itself, my preference would be to try to get all the x's onto one side first. How do I do that?
Minus 3.
Yeah, we can subtract. Well, if I subtract 3, the problem is that 3x minus 3 doesn't simplify because those aren't like terms. I could instead subtract 3x from both sides. And then that would work because 3x minus 3x is going to combine to 0. 8x minus 3x is going to combine to 5x as like terms. So that seems like a good strategy because that gets rid of all the x's on my left-hand side and moves them over to my right-hand side. We could have also done the same, we could have achieved the same end, by subtracting 8x instead of subtracting 3x. I'm actually going to take that route just so that I can make another point out of this. But because now I'm going to get negative 5x, I'm going to have no x's left on the right-hand side, and then everything else is going to remain the same. Okay, after which I want to subtract 17 from both sides, which when I subtract from the right-hand side, 14 minus 17 is going to give me negative 3. I have a less than or equal to here, and I'll have negative 5x. And then my last step to get that x by itself is going to be to divide by negative 5. Which is going to succeed at getting the x alone. But what's the other thing that we have to remember at this last step of the inequality? So negative 3 divided by negative 5, that I can just rewrite as positive 3/5. But what else happens here? Yeah, it flips. And how do we know why it flips? Or maybe the better question is, when do we flip an inequality?
You divide by a negative number.
Yes, exactly. We divided by a negative. Divided by a negative. And so this inequality has to flip from less than or equal to into greater than or equal to. And so that gives us the solution for our inequality, written as an inequality. So one of the things that we could do at this point is we could write our answer, just flesh this out a little bit more, write it out as a set, because that's what a solution to an inequality is. It tells us what is the set of all possible real numbers which satisfy this inequality. And so for that, we'll use what's called often set builder notation, where all we do is we take this inequality which characterizes x. So I call this the characterization. This tells us kind of the cost of membership in this set, characterization. Which x's are going to satisfy this inequality? They're the x's that are greater than or equal to 3/5. But we also need to specify where these x's come from. And that's what the rest of set builder notation does. So it uses these funny curly braces on either side. And it also tells us that x is the variable that the solution is quantified on. So this is the quantification step. Quantification, where are these numbers coming from? These are just x's. We could also decorate this more. I don't think that our textbook does this. We could also decorate this by saying something like x is a real number. And then there's a vertical bar. But I think that the way our text does it, it just does it this way. And then the vertical bar is read in English as such that. So it's just a way of repackaging an English sentence using notation. So we could read it as it's the set of all x's such that x is greater than or equal to 3/5. That's how set builder notation is built up. As far as I'm concerned, if you're solving an inequality on an exam and you just sort of leave your answer as something that looks like this instead of this set builder notation, that's fine. It's fine by me. But if the question asks you to go further and write your answer in interval notation, then we have one more thing to do. So let's do that thing to finish up our conversation here. So if I want my solution in interval notation, then what I'm really asking for is I'm asking for what are the lower and upper extents. So how small do these numbers get, lower endpoint, and how large do these numbers get, upper endpoint. And we're going to use the lower and the upper endpoints to give us a new way of writing this solution. And my recommendation for this is always to start out by sketching our solution on a number line. So here on a number line, maybe I'll just put some numbers, 1, 0, 1, 2, 3, 4, -1, and so forth. 3/5, +1, +2, +3. 3/5 is in between 0 and 1, so I'm just going to kind of mark that right here. 3/5. So my first question is, if I'm going to color in that part of the number line which satisfies this inequality, am I going to color to the right of 3/5 or am I going to color to the left of 3/5? Always to the right on this example because
X is
greater than. And the meaning of the word greater than is to the right on the number line of. Right? That's one way of defining what it means to be greater than. Okay, so we now know, based on this drawing, what is the lower endpoint? How far to the left on the number line do our solutions go? 3/5. So we're going to use that as our lower endpoint in our interval notation, 3/5. How about the upper endpoint? How far to the right on the number line do these solutions go?
anything greater than or equal to.
Anything greater than or equal to this. So is there an upper limit? No, because there's no upper limit to the real numbers. So we'll use an infinity symbol to indicate that this doesn't end as we go off to the right. So that's the lower endpoint, that's the upper endpoint. We'll stick a comma in between them. But now here is where people feel like they go off the rails because they have trouble distinguishing between what notation to use to complete this interval. Because the last thing that we want to do, the one thing that this picture doesn't answer for us yet, is what about the number 3/5 itself? Does 3/5 belong to our solution set or not?
Yes,
It does. How do we know that, first of all?
It's like because of the equal.
Yes. Because greater than or equal to affirms the possibility that 3/5 itself does in fact belong to the solution set. If we plug in x equals 3/5, this inequality, 3/5 greater than or equal to 3/5, is satisfied. Right? Because it is true that 3/5 is greater than or equal to 3/5. And so because that answer is yes, what notation do I want to use next to the 3/5 in my interval notation?
Square bracket.
A square bracket. There we go. So the square bracket tells us that the number 3/5 itself is included in the solution. What about the infinity?
Round.
Round bracket. And why does infinity get a round bracket?
So the rule is always.
Yeah. Right. Does infinity itself belong? Is it a solution? No, because infinity is not a number. So infinities and minus infinities will always get round brackets. But finite numbers like 3/5, we have to decide. Based on the kind of inequality that we have, is it itself a solution or is it not? If the answer is yes, then it gets a square bracket. If the answer is no, it gets a round bracket. One of the cues that can kind of cue you into this and help to build intuition is that the strict inequalities, less than, greater than, these always, almost always, correspond with round brackets. And the non-strict inequalities, like the ones we worked with in this problem, the greater than or equal to's, the less than or equal to's, those almost always correlate to square brackets. It's actually really hard to come up with an example where that's not the case. So anytime you see a less than or equal to, greater than or equal to, you should be thinking about square brackets. But when in doubt, just plug it in and check it and make sure that the number that you say is actually part of the solution set really is part of the solution set.